Hello. In this video we're going to work through this question here. We're going to solve the linear system using graphing, and then we're going to prove our answer using substitution or elimination. So remember, a linear system is two or more linear equations, and the solution to a linear system is the point of intersection, that is where the two lines touch. So the most straightforward way to solve these types of problems is to graph them. So that's what we're going to do here. So the first thing I'm going to do is number the equations, which I've done here. And then I'm going to rewrite each of them in the form y equals mx plus b. The reason I do this is because y equals mx plus b is a very convenient way to graph. So we get 2y equals, and I'm going to put the minus x first, plus 6. I subtracted x from both sides. So y is equal to minus x over 2 plus 6 over 2. Remember to divide both terms by 2. And y is equal to minus 1 over 2 x plus 3. So we see here that this has a y-intercept of 0, 3 and has a slope of -0.5. This is all the information we need to graph this line. So now let's do that for the second equation. So x plus 2y equals 2. So we get 2y is equal to minus x plus 2. And we can do this now in one step. Divide the whole side by 2, 1. And so we see now we have a y-intercept of 0, 1, and we have a slope of -1 over 2. So now we want to graph this. So I'm going to graph this by first making my Cartesian plane. And whenever I make my Cartesian plane, I always want to make sure that I put the name of the axes. This is the x-axis. This is the y-axis. Actually, let's make this a little straighter. Let's try that again. I'm going to come, there's my Cartesian plane. This is my x-axis. This is my y-axis. And I'm going to put 1, -1, 1, -1. That shows my scale now, and I can easily count off the values. So let's do this first line, equation 1 in blue. So we see we have a y-intercept of plus 3. So first thing I do is I put the y-intercept, and then I count the slope. 1. So I have a slope of down 1 over 2. 1, 1, 2, 1, 1, 2. And then I just connect the line. So we just kind of connect that, and it kind of goes like this. So there's my first line. Now let's do our second line. Let's do the second line in pink. So I'm going to come down here, I'll underline this line in pink to help me remember. So we see we have a y-intercept of 1, so I put the mark at 1. I go down 1 over 2, down 1 over 2, and go up 1 back 2, up 1 back 2, up 1 back 2. And on the computer it's a little tricky, but if I was doing this on paper, I'd get a ruler out and kind of connect the dots. And now my question is, well, what do we notice here that's funny? Well, take a look. These lines are parallel. So if they're parallel and they have a different y-intercept, will they ever touch? So if I imagine starting here at y is 3, if I go over 2 and down 1, and if I start at y as 1, I go over 2 and down 1, they're moving down at the same rate. So they're never going to touch. That means this linear system has no solution. They never touch. So now this is great because you graph this, but again, they're not always going to be equations that are so easy to graph. So this is where we want to fall back on either our substitution or elimination technique. So I'm actually going to use substitution, and the reason is because notice the work here I did at the start. I have y equals -1/2 x plus 3. I have y equals -1/2 plus 1. It's really easy to substitute this. So if I know that, let's say equation 1 can be written as y equals -1/2 x plus 3, and equation 2 can be written as y equals -1/2 x plus 1. I can set 1 equal to 2. So I can get -1/2 x plus 3 is equal to negative 1/2 x plus 1. And now let's do some, made a little writing mistake there. Negative 1/2 x. Now I can do a little bit of algebra. Let's multiply everything by 2 to get rid of that denominator. So I get negative x plus 6 equals negative x plus 2. So we just cleared our fractions here. And now we do a little rearranging. So we get negative x plus x is equal to 2 minus 6. So I get 0x equals negative 4. And then I say to myself, well, 0 times anything is 0, so this doesn't make sense. And in fact, this is the special case that you want to look for when you're applying the approach of substitution or elimination for a system with no solutions. So since 0x equals negative 4 is impossible, there are no solutions. And what mathematicians say in general, mathematicians say the following. If you get a situation that is 0x equals a, where a is an element of the real, meaning a is a real number, that means your system has no solution, which is the case when the lines are parallel and have different y-intercepts. As always, please feel free to ask lots of questions. I encourage you to, and I hope this video helped. Have a great day.